The question we are solving now belongs to test series 1. It is of network theory subject. In specific, it belongs to DC network solution methodology. As per the question, there is a DC network given which contains a 1 ampere current source and 4 resistors which are connected as shown. And the resistors have resistances of 8 ohms, 3 ohms, 10 ohms, 4 ohms, and it is given that this network is identical with another network which has an I ampere current source in parallel with a R ohm resistance. We need to find the value of R. From the two circuits given, we see that the network on the right hand side is the Norton equivalent of the network on the left hand side. From this we see that R can be expressed as Norton resistance, which is equal to the resistance as seen from the terminals X and Y. For finding Rxy, we see that as the circuit contains only independent sources, Rxy can be obtained by finding the equivalent resistance as seen from X and Y. For finding the same, we have to replace the 1 ampere current source by open and the voltage circuits by short. So upon doing this, we see that the equivalent circuit can be drawn as shown. Which will have the resistors as marked and the 1 ampere current source is replaced by open. From this we see that Rxy is equal to 4 plus 3 in parallel with 18. This quantity when 3 in parallel with 18 can be written as 4 plus 54 divided by 21. This can further be simplified as 4 plus 18 divided by 7. This upon simplification becomes 46 divided by 7. From this we see that as the circuit contains only independent sources, R is equal to the Norton resistance, which is equal to Rxy, which is the resistance as seen from XY terminals, and this is equal to 46 by 7 ohms. From this we see that the value of R is 46 by 7 ohms. Hence, the correct option is D.